Hi mates, what is up? In this video I shall introduce Java to you and generally how high-level programming languages are translated. In the third video of this playlist we had a glimpse of language translators. I highly recommend that you go check that one first, then come back to this one. I will drop the link in the description below. I am so excited to tell you that today's lecture will start with an interesting story. A story of how Java came into existence. I bet you don't want to miss out, so stick around and get excited too. In fact, I am more than eager to start, so let's dive right into it. It all started in the early 90s when James Gosling with two of his teammates initiated this great project. At that time, it wasn't Java, but Green Talk, derived from a name of a small team called Green Team, a team made by James and two of his colleagues. Fast forward, Green Talk was renamed to Oak, which originated from a giant oak tree that stood out of James' office. The Green Team could not know what their idea would turn to as they had smaller vision. But Oak's power and capability kept manifesting themselves uninterruptedly. Hence, there was a compelling need to change to an exceptional name and trademark. So in 1995, James was inspired by a cup of coffee he was sipping called the Java coffee, arguably the best coffee of its time. Here are we, and there was where it got its name from. So Java programming language got its name from a coffee? Yes sir, that was why it made a hot cup of coffee its trademark. Wow, does that mean I have to be a coffee addict before I master Java? Well, I don't know. In a remarkable turn of events, Java was reported one of the top 10 best products of the year. To tell you how promising Java is, it can be used for lots of applications, some of which are web applications, mobile applications, game applications, enterprise applications, scientific applications, and IoT, which means Internet of Things. Java has been the foundation of many successful projects like NASA Worldwind, Spotify, Google and Android OS, Netflix, Uber, Amazon, etc. Not only that, Java has powered the core of many technologies like smart card, space vehicles, robots, etc. At the time of recording this video, roughly 13 billion devices run Java, and the average salary of a Java developer in the USA fluctuates around $100,000 US per year. That could be you earning such heavy amount of money as a reward for knowing Java. So wake up. Indeed, Java is a popular programming language that cannot be abandoned. Its impact and that of other prominent programming languages made object-oriented paradigms stand out of other paradigms. Of course, it wasn't just the name Java that gave it its popularity. It has other outstanding features which are simplicity. Though Java might have a steep learning curve which would make it relatively hard for beginners, its core is easy to master because it's not as dynamic as languages like JavaScript and Python and their likes. Another feature is object-oriented, and generally object-oriented programming languages have simple concepts. They are easily used for modeling real-life entities. They allow reusability of code, which is inheritance, and other cool things like polymorphism, abstraction, encapsulation, etc. We will look at all this later in the course, so you don't have to worry about it. The next feature is security. Java programs are optimized during execution, so they don't extravagantly access your computer resources, and that reduces the threat of virus and cyber attacks. Another one is high performance, then multi-threading, and finally, and the most important one, architectural nature. The major thing that made Java popular is how it was built to be platform independent. And that is what gives Java the ability to run exactly across different platforms. We shall look closer at this platform independency in a second, but let's try to understand what a platform is in the first approach. Well, platforms are simply the environments where our programs run or execute. In this case, our platforms are our computers. So technically, platforms are made up of hardwares and softwares. As you can see here, software plus hardware equal to platform, or the other way around, hardware plus software equal to platform. It doesn't matter. So when we say software, particularly we mean the OS. And when we say hardware, particularly we mean the processor family. So the operating system plus the processor family gives us platform. So example is Windows. We all know Windows is an operating system and Intel is a processor family. So Windows plus Intel equal to what? Wintel. So this Wintel is a platform. Another example of platform is Power Mac, which is the Mac OS plus the Power PC. The Mac OS is the operating system for Apple computers, and the Power PC is the processor family Apple computers come with. So that is simply what a platform is. I can't say more that you should watch the third video in this series if you haven't, because there I discuss the three categories of programming languages, which are the machine language, the assembly language, and the high-level language, under which we learn the three language translators, which are the assemblers, the interpreters, and the compilers. We also learned that the assemblers are a piece of programs that translate assembly language to machine language. Interpreters are a piece of programs that translate high-level languages to machine languages at runtime, one instruction at a time. And the compiler is a piece of program that translates high-level languages to machine languages at compile time once and for all. A lot of things were discussed there, so talking much about them here will be redundant. So as I said, I will leave the link in the description below for you to go and watch. Now that we have briefly revised what these translators are, let's look at how programs are compiled in the traditional compilation process. By traditional, I mean any language that is not Java and that does not use the Java compilation process. So let us assume our traditional language is Visual Basic, VB for short. On one hand, we have the Visual Basic source code, which simply means the code written by a programmer. This source code is saved with the extension .vb, very important. On the other hand, we have the machine code or the object code, which is saved with the extension .obj. Do you remember that each platform has its own versions of zeros and ones? So this object code is nothing but a binary representation of our source code, which is understandable only by the platform it is compiled in. Assume that my computer is Wintel, which is Windows operating system running on an Intel processor, right? So if I get a copy of this source code and I compile it on this platform, the object code cannot be taken to another platform. Straightforward, right? Now let's look at a more complex example. Suppose we have three different source codes, each depending on the others. Meaning A1 depends on A2 and A3, A2 depends on A1 and A3, A3 depends on A1 and A2. So each source code gets compiled individually to a machine code. A1 gets compiled to A1.object, A2.vb gets compiled to A2.object, and similarly A3.vb gets compiled to A3.object or .obj. Now, even at this point, these three object codes solely depend on each other. So in order to get the program working properly, they have to be linked by what we call a linker. So this linker will link these three .obj files together and produce what is known as .exe file, which means executable file. So the result of A1.obj, A2.obj, and A3.obj is A.exe. Just like the obj file, the exe file remains a machine code too, so it is understandable by the machine, and this is what will get executed. That is all for this video. In the next video, we will cover the compilation process in Java. See you there.